Now, there are different types of reaction. Number one reaction is combustion. This is where a substance will react with oxygen, and this simply means the substance is burning. All right, so we would say alkanes, actually alkanes, alkenes, and alkynes can all do this, would react with oxygen to produce carbon dioxide and water, even alcohols, because we can talk about fuels. All right, now that's the first thing. Number two, then we talk about substitution, elimination, and addition. All right, substitution, elimination, and addition. And we have, in crazy physics, we have a simple way of putting all of these three together. All right, I'm going to tell you a story, and if you've been following, you would know the story. Think about someone who's single and seriously searching. So we would come here and say single and seriously searching, who went to the United States of America and found a girl called Sue. All right. Now, what does this quickly tell you? Remember the story? Single and seriously searching, went to the United States of America and found a girl called Sue. We are simply saying, guys, if you move from a saturated compound to another saturated compound, let me write it on the side. Let's break this down. I need a white. Okay. And we move all of this down. I'm going to compress my reactions on one page. Most of the things I need about a reaction. So if you move from a saturated compound and your product is also a saturated compound, you are simply talking about a substitution reaction. All right, so if my reactant is an unsaturated compound and your product is a saturated compound, you are simply referring to an addition reaction. This works like fire. If you have a saturated compound and you move over to an unsaturated compound, you are simply talking about what? Elimination. So you just need to check. If you identify if it is saturated, it's an unsaturated, you know what to do. SSS, USA, and SUE. Done. You don't want to waste too much time, and you will see how I would use all of this. Now, let's talk about simple conditions. All right. Simple conditions for a reaction. I want space. I want this compressed on one page. Remember, guys, subscribe to our YouTube channel. Please be kind enough, if this video is helpful, leave a comment. All right, for somebody else who would see this video, they would actually work on your recommendations and also use the video. If it helped you, it can therefore help them. Now, what are the conditions for reaction? Simple conditions for reactions. Just going to summarize this for you. Now, we talk about, remember this guy was single and searching. Now he met a girl called Sue. Obviously, they are going to wed. All right, so Bishop weds Sue. But I'm not going to use the word weds. I am going to change my W into a C. All right, conditions for reaction. Now, this one tells me that I am using a concentrated acid or base. Concentrated acid or base. C for concentrated. Anytime you deal with a concentrated acid or base, the reaction is going to be elimination. Your E remains the same from the top there. And automatically D talks about what? Dilute acid or base. Every time you use dilute acid or base, you are going to talk about what? A substitution what? Reaction. All right, beautiful stuff. And with elimination, guys, let's talk about heat now. Another condition. Guys, when you say something is eliminate, you got to be strong to remove someone, eliminate. So if it is heat, Let's do this just to make it. We want to talk about heat. All right. Now, to eliminate, you need strong heat. All right. Everything about elimination is just, it has to be strong. It has to be concentrated. It's the tough stuff. All right. When it comes to, what's the other one? Substitution. What do? You need mild heat. Listen, if you remember this, I promise you that you have almost answered all your questions. Okay? Are we okay here? So we have SSS, USA, SUE. Now, we have our conditions: concentrated, we talk about elimination; dilute, we talk about what? Substitution. When it comes to heat, strong heat, you eliminate with strong heat, and then you talk about mild heat to substitute. So if they ask you for two conditions, condition 1 here and condition 2, and you move to the next question, you don't want to waste time. All right. Then you have what we call Markovnikovs rule. Markovnikov, this is my cousin. Markovnikovs rule. All right. And basically we are saying the rich gets richer. That's a bad principle. The rich gets richer. All right. That's just a principle to use in remembering. So we're saying in an addition reaction, all right, the carbon atom, or let's say the hydrogen atom, let's use the hydrogen as a reference, all right, is added to the carbon with more. All right, in an unsymmetrical unsaturated compound. Remember, we talk about an unsaturated compound will go through addition reaction. Unsaturated compound. I'll explain this as we move along. So just know that the carbon atoms that has more hydrogen would receive the hydrogen atom. All right, and then you have the second one, which is the Zaitev's rule, and this works for elimination. When you eliminate, what do? You remove. No one is going to ask you to state this, but you need to apply. You remove a hydrogen atom from a carbon that has more. A carbon that has more. So it's all about the rich. The rich gets richer, and then when we remove it, we also take from the rich. So you have your Markovnikovs rule and your Zaitev rule. We should be able to apply that as we then move on. And the last one I'm going to talk about, two more, esterification. Esterification. I like the ACE brand. All right, the ACE brand of millennial. Now, if I have ACE, I cannot eat ACE without water. So I need ACE and water. So basically, esterification, we talk about an alcohol. My spelling. I didn't drink alcohol, don't worry. Alcohol plus carboxylic acid, all right, would give us what? Ester, that's the E, plus water. Now, in the presence of concentrated sulfuric acid. Oh, by the way, do you see? We are eliminating. If I take you back to one of the conditions of elimination, let's go. Concentrated acid or base. We are going to do what? Eliminate. So here, we are eliminating water. So we eliminate, which is actually dehydration. We are deleting water. And why do we use sulfuric acid? Sulfuric acid is a dehydrating what? Agent. That is the property that makes it suitable to act as a catalyst. So it will act as a catalyst because it is a dehydrating agent. Dehydrate means to remove what? Water. And by the way, the mixture is heated. Remember, elimination, we talk about heat, but this mixture is heated in a water bath because alcohol is flammable. You cannot expose this to naked heat. Alcohol is highly, not just flammable, let's put the word highly there, highly flammable. So we use a water bath. This is a very common question. We use a water bath because alcohol is highly flammable. So this is esterification, which is also an elimination what? Reaction. We are removing a molecule of water. Okay, I hope we'll be able to. Let me just try one quickly with you. For example, butanol plus propanoic acid. What will that give us? Let's just do one example quickly. But is 4, so I have 1, 2, 3, 4. All right, and since it is an alcohol, we are going to write this way for clarity and in a simplified form. Now, when I talk about my propanoic acid, COOH, see, just for clarity and to have it simplified, we would write this way, and then we have the other 3 or the other 2 carbon atoms, propanoic. Now, what do we want to do? We want to remove what? Water. Look at what I'm going to do here. I like a smart board. It just makes my life easy. Okay. Did I get it right? All right. Lovely. So I want to remove water molecule. I'm going to just draw a box around my water. Water is H2O, so I'm going to remove one hydrogen from the alcohol and remove the hydroxide from that. So I have my water molecule. So if I come here and remove that same water, remember, I'm going to remove hydrogen and I'm going to remove this guy. So what do? I'm going to just close the gap now. Done. Plus H2O. And please, when you write your water structurally, you must write it like that. And that is esterification. So butanol plus propanoic acid will then form butyl propanoate. That's the ester. Esters end with know it. I hope this crash course makes sense. All right. Finally, before we look at question, difference between hydration and hydrolysis. Hydration and hydrolysis. Quickly understand, hydration is the addition of water. So it's an addition reaction. Hydration. So we talk about an addition reaction. These are the basic things that you need to remember. And hydrolysis is reaction with water. So if we are reacting with water, it becomes a substitution reaction. And remember, once you talk about a substitution reaction, what do you need? You need a dilute base or even an acid, and you need what? Mild heat. So take note, hydrolysis. Hydrolysis is substitution. All right, awesome. Let's go answer our question. I hope my crash course has been absolutely beautiful for you. Let's quickly answer our questions as we go on. All right, I hope you have just asked someone to get you a cup of water because you don't want to stand up and miss out on this. All right, you just ask your brother, ask your mom, ask dad. Dad, please get me a cup of water. I don't want to miss this thing. This thing is beautiful. All right. Now, the balanced equation. Oh, I didn't talk about polymerization. Let me just quickly go back and talk about polymerization. Polymerization. So when we talk about polymerization, we talk about polymers and monomers. Polymers. All right. So polymers are formed from repeated units. Polymers are formed, it's a crash course, from repeated units of monomers. Repeated units of monomers. Repeated units of monomers. The word mono simply means one, and the word poly simply means what? Many. All right. And there are two types of polymerization. Types. There is what you call condensation or addition. Let's start from addition. Addition polymerization. Now, once I say addition polymerization, do you remember when we spoke about addition reaction, we talked about USA? Oh, so I'm going to have unsaturated monomers. Monomers. All right. And that will give us what? A polymer. Not just a polymer, we are safe to say a saturated polymer. I'll give you a quick and a common example. Is your alkene, or let's say ethene. Let's be specific. Ethene. F is 2 carbon atoms. So basically this is what you have. You have your ethene. All right. Plus another ethene. We have many of them. All right. A lot of them. This looks untidy. No. Ethene, double bond. All right. So my monomer is then ethene. What will I then form? I'm going to form many ethene. So this is ethene monomer. I am going to then have many ethene, and the word many is simply poly. So this is how I'm going to represent that. I'm going to represent now with single bonds, because we talk about saturated. However, because there are many and I cannot write all of them, I am just going to come here and write one repeated block of ethene. That's a repeated block, and write N there. So we are repeating this block. Oh, let me put 3 dots. It continues. Let's try to. Okay. Plus so many of them to give me that. So this is called polyethene. And why is this very important? Polyethene or polyethene uses. 1, it is used in making squeeze bottles. 2, plastic bags. 3, bulletproofs. So it is very, very important. Uses of poly. Either you call it polyethene or polyethene. So your plastic bags are actually called polyethene bags. Alright, so it's very, very important. If you need to know any one of these polymers, this is the one you should actually not forget. Now, we spoke about addition polymerization. There is also condensation polymerization. Now, when you condense, you are actually eliminating. So we have condensation polymerization, which is an elimination reaction. All right. And when you condense, okay, remember it is elimination. Where do we have elimination? It's SU. All right. Good. It means we are removing. All right. So monomers are combined. Monomers are added together to form polymer. to form polymers with loss of water molecule. That's the condensed. So we remove from them with loss of water molecules. So once you see monomers, many of them, all right, and that gives you a polymer plus water. You already talk about a condensation. You are reducing and removing. All right, you need to remember that. Okay, conclusively, I am just going to talk about cracking. Now, cracking, when something cracks, you're talking about the breaking down of large size organic compounds into smaller units. Organic compounds into smaller usable units. And there are two types of cracking. There's what you call thermal cracking and catalytical cracking. And this is just simply using what? Heat. And this is using a catalyst. Okay, I'll give you a quick example. I could then have something like C20H42. All right, that's a very large compound there. And when this breaks down, it needs to break down into different smaller units. So I could have it breaking down into C3. This is just an example. C3H8 plus, I could have 2 of that. Now, so the whole idea here is to count. Already, what do I have? I have 6 out of what? 20. So I'm left with what? 20 minus 6. I hope you understand the 6 there. 20, this carbon 20 minus 6 carbons will be left with what? 14. So this needs to break down into other compounds. So 14, I could then have what? I could have C5H and then plus what? C2H. It depends on what the examiner wants to check with you. So you need to make sure so that if you count, then you have the same number of carbons. So basically, you are trying to balance. All right. So if I have, this is 6 plus 5, 11. No, my math is wrong. 6 plus 5, 11. And I'm going to 20. I need to take that down. That 2 must be out. All right. Remember, I could have, let's make it easy. Let's make it easy. C5H10. Okay, let's check something here. If I have 2 there, then that's 10. 10 plus 6 would give me 16. Then I need 4 more. So I could have C4H. I hope that makes sense. You just need to count. 6 plus 10, 16. Plus 4, 20. What about the carbon atoms? 2 times, this is just a rough estimate. 2 times 8 will give me 16. 16 plus, this is 20. 16 plus 20 would give me what? 36. Okay, my calculation, my compounds are just a bit messy, but the whole idea is to count. You have an alkane and then you have a saturated compound and unsaturated compound. What will this give me? C4H, we just need to balance. C4H, wait, we said 6 here. Oh no, it's minus 42. All right, so I'm good. 2 times 3 will give me 6. Let's pick a calculator. 2 times 3, so 6 there. No, I'm looking at hydrogen rather. 2 times 8 will give me 16. Plus, that will be 20. That will be 36. But on the side, what we have? 42 minus 36. And that will give me 6. All right. So this gives me an alkyne, this gives me an alkene, and that gives me an alkane. So basically, when you see this type of question, you just need to add because you are breaking down. Polymer, we are building up. Cracking, we are breaking down. Okay, haven't summarized all of that, let's quickly answer our question on organic reactions. All right, the balanced equation for a polymerization reaction is shown as that. Okay, for clarity, I'm just going to write this. This is what this examiner wrote. This examiner wrote in there, which is the example that I gave. Mind you, please, here, let me just say this, very key. The bracket is there, but my hyphen, my bond, extends beyond the bracket. N. Now, 4.1.1, write down the type of polymerization reaction represented by the equation. We're moving from unsaturated to saturated. So number 1, 4.1.1 is an addition polymerization. Easy stuff. Ooh, I'm sure you're going to have it so easy on Monday. Addition polymerization. 4.1.2, IUPAC name of the monomer. Monomer ethene. IUPAC name of the polymer, polyethene, many ethene. And we are done. Good. Let's go to the next page. Let's close this page so we have our question again. Now we want to go into reactions. So that was just polymerization there. And the thing they could have asked us is the uses. And I gave you 3. All right. Now look at how I'm going to deal with this other section. I have propan 1-ol, and I have compound Y. I have this, which is written as compound X. I have a reaction here, and I have compound Z called a major product. Would see reaction 1, and I have HCl. Reaction 2, I have concentrated sulfuric acid, okay, and I have H2O and concentrated sulfuric acid as well, and I have reaction 3. Okay, now propan 1-ol, which is an alcohol, and we can actually say alcohol, can group it under saturated, single carbon atom. All right, undergoes 2 different reactions as shown in the diagram below. Write down the type of reaction represented by 2. Hold on. When you see an alcohol and you see a concentrated acid here, there is something that the examiner wants to get right here. All right, now 4.2.1, guys, I told you, whenever you see a concentrated, you know you are dealing with elimination, CEDS. So here we are going to then deal with an elimination reaction. And basically we are removing water, so we could be specific and say dehydration. You know what gave this away? Concentrated sulfuric what? Acid. Now, function of concentrated sulfuric acid in reaction 2. I told you already, this has been answered. This is a catalyst, or what you can then call a dehydrating what? Agent. Everything has been answered, guys, while I was doing the summary. All right, the function, it's a dehydrating agent, or it speeds up the rate of reaction by helping to remove water. Now, IUPAC name of compound X, the best thing is to draw. Let's go draw propan 1-ol and remove water. Okay, on my fresh page, let's have propan 1-ol, and let's see what's going to happen. My advice is to always draw. All right, and you know your OH would just be there. Now, what does the rule of dehydration here says? I need to remove Remember, we're saying dehydration because we're using a concentrated acid. Okay, so I need to remove a water molecule. How do I then remove a water molecule? I am using concentrated sulfuric what? Acid, because it acts as a catalyst because of its dehydrating property. So it is a dehydrating agent. Now, water is H2O. The first thing is I am going to remove my hydroxide ion. All right, guys, you don't remove the hydrogen from the same carbon. Listen to this. After removing your hydroxide ion, just gonna put a note here. You remove hydrogen from the carbon with the least number of hydrogen rather. All right, so I have removed this hydrogen. I have removed my hydroxide ion. I need to remove hydrogen because I need to form water. All right, now the question is, which hydrogen am I then going to remove? I have two other ones there. Basically, you remove the adjacent one, the one next to it. Peradventure there are more than one, then you need to remove one with the smallest, the least number of hydrogen. So in case this was in the middle, then I need to remove one, especially if it's unsymmetrical. I need to remove one that has, I need to remove hydrogen from the carbon that has the least. This is 3 and this is 2. So I remove from here. Now we can have our structure back. Let's see. 1, 2, 3. Hydrogen, 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 plus that. Now there's a problem there. Now, do you notice that carbon is supposed to have 4? It's a valency of 4. But there is a missing hydrogen. So what am I going to do? I am going to put a double bond because we move from saturated to what? Unsaturated. Elimination. And what's the name of this compound? It is prop-1-ene. Double bond. Double E. All right, sitting on carbon number 1. Please take note of the process. After removing OH, after removing your hydroxide group, what do you remove? Remove hydrogen from the carbon with the least number of carbon. And basically, we're talking about the adjacent carbon atom. And that's how we answer that question. Prop-1-ene. Okay. IUPAC name of compound X, which we just did. The structural formula of compound Y. Oh, let's go see something here. So already we have this as prop-1-ene. Hold on. I now have water and concentrated sulfuric acid because we're looking for Y. Sorry, we're looking for Y. So I have that and hydrochloric acid. Again, guys, please draw. Let's check the diagram. Propan 1-ol. It's just easy when you draw. Propan 1-ol plus hydrochloric acid. You can actually predict when you draw. In case you're struggling with this, draw. So you have your OH, you have your hydrogen, hydrogen, hydrogen. All right. Plus HCl. What are we going to form? This is a saturated compound. I see that we can actually talk about a replacement because they are both negatively charged. So they can actually replace each other. And when they do, we talk about what? A substitution. Hold on. I want you to see something here. This examiner is very clever. Let me take you back to the question. Look at what this examiner has. All right, we have HCl, hydrochloric acid. So basically we have your hydroxyl group, OH, and your hydrochloric, your chloride group. They are both negative. All right, so we can just simply swap them. And once we swap them, what are we doing? We are substituting. So what are we going to have? 1, 2, 3. Your original number of carbon atoms would remain the same. And I have my chloride there. I have that. I have that. I have that. Plus, now, if these ones are swapping, it means I'm still going to produce what? H2O. Let's use structures. Good. And what is the name of this compound? It is chloropropane. I hope it makes sense, guys. If you just draw, it makes things easy. And it takes you seconds to draw. You can't quickly see what's going to happen. We're almost done with that reaction question. Wow, organic chemistry is so beautiful. All right. The type of reaction represented in reaction 3. I want you to notice that in this case now, we are adding water. So there is water added. Why? How do I know there's water added, guys? Your X, do you remember what X is? X is unsaturated. And there is only one reaction that starts with U. Check this. I want you to check this. Unsaturated, it's a U. Oh, it's an addition. And now I have water added. So if I'm starting from unsaturated, I can then only have it ending as a saturated. And with water, then I have that. So let's quickly answer the question. What type of reaction is that? That is 4.2.5. It is going to be what? Addition. And because it is water, we can specify to say hydration. All right. Let's look at the last question, 4.2.6. I'm sure you're learning quite a lot here. IUPAC name of compound Z. All right. Again, what do? You draw. Prop 1 in. So we have prop 1 in. Let's see. Prop 1 in. No, we shouldn't be having that there. It's a double bond. Prop 1 in. 1, 2, 3, 4. All right. Plus H2O. We are adding water. What are we going to have? Look at what I'm going to have. Let's draw this other side first. We already know that we are going to have an addition what? Reaction. So I am drawing all of that. But what is going to happen here? This water molecule will break down into hydroxide ions and what? Hydrogen. Now the question is this. How do I know where my hydrogen is? This is where you talk about Markovnikovs rule. The hydrogen atom will be added to the carbon that has more. Let's look at this. The hydrogen atom will be added to the carbon atom that has more. There are 2 spaces available here, but this carbon has 2 hydrogen and this carbon has 1 hydrogen. The rich gets richer. The hydrogen will be added there and your OH comes here. So what is the name of this compound? I hope you understand the Markovnikovs rule now. This is prop because it's 3. So we are going to have propane. Don't forget the AN. This is on carbon 2 all. Beautiful. Propane 2 all. It is always easy when you draw. Please get this video. Go back to YouTube. Download and watch again and again. Understand Markovnikovs rule. Understand what I did there. So I did 2 things that are very important here. Number 1, in removing water, how do I remove it? Remove the OH. Even if it's a Br, halogen, you remove that first. And you remove hydrogen from the adjacent carbon with the least number of hydrogen atoms. Please, that's very key. And number 2, when you add, okay, here we went through substitution where we took and replaced. Is that okay? I like this question because we've gone through the 3. Addition, reaction here. Remember, you're starting from unsaturated. That's a scale saturated addition, and we call it hydration. And how do you add? The same thing. This way is the same way you're going to add a haloalkane. You take the hydrogen and drop it on the carbon that has more. The rich gets richer, and you are dead done. Guys, I hope you enjoyed this section of organic chemistry. Now we are going to the next section, which is rates of reaction. All right, rates of reaction. Please be able to define rate of reaction. All right, it is the change in concentration of products or reactants, and when we say rate, we introduce the clause per unit what, or the phrase per unit what, time. Very key. The change in concentration of product or reactant per unit. Do you know I just skipped now to 5.1 and we are done. But quickly, a summary. Factors that affect the rate of reaction. Factors that affect rate of reaction. Factors that affect the rate of reaction, and how each of these factors then affect. We're going to look at that and then deal with the questions. All right, number 1.